Uh, Good afternoon. This is BS Math Faculty for IIT JEE at Infinity Learn. Very happy to see you here, dear students. Yeah. So today we shall discuss inverse trigonometry related content. Right. You see, first of all, welcome to Infinity Learn by Sri Chaitanya. You see, in this series, we have been discussing important topics related to JEE mains. One such topic is inverse trigonometry, which is small in size but very easy also to score 4 marks in JEE main. Almost in every paper, you can expect one question from inverse trigonometry. Right, dear students. So first let us recall some important set of points related to inverse trigonometry. Point number one, friends, as the basic trigonometric functions, sin x, yeah, I can say cos x, tan x, you see secant x, cosecant x, and cot x. These functions are not bijections on their respective domains. So we restrict their domains and we make them bijection, then we define their inverse trigonometric functions. You know the functioning of all these. Since it is a revision class, I can say, friends, sine inverse function domain is -1 to 1, whereas we define its principal range as minus pi by 2 to pi by 2 closed interval. In the same way, friends, cos inverse x domain is also -1 to 1, range is closed 0 to pi, whereas for tan inverse x function domain is r, whereas the range is minus pi by 2 to pi by 2 open interval. In the same way, friends, you can take cot inverse x, domain is r, the range is open 0 to pi. Even you can take secant inverse x, the domain is minus infinity to -1 closed, union closed 1 to infinity, whereas the range of this must be just like cos closed 0 to pi. Of course, you won't get pi by 2 as output. Whereas cosecant inverse x domain is the same, range is like sine inverse x minus pi by 2 to pi by 2 closed except 0. Friends, in the problems, of course, the domain part, domain, whereas range. These two are going to play a vital role. So especially range. Fine, friends. One important point is sine inverse x, tan inverse x, and cosecant inverse x have range like minus pi by 2 to pi by 2 kind of. You just observe these two. Whereas other three, cos inverse x, cot inverse x, secant inverse x, have their range like 0 to pi kind of. Yes. So the behavior and formulae all will be alike for these three functions, and for these three functions the formula will be alike. Let us see this point. Okay, this is formula set 1, friends, the domain and range of the 6 inverse trigonometric functions. Then second point, dear friends, we can observe that sine of sine inverse x function and sine inverse of sine x function both are not the same. Here the domain is just -1 to 1, whereas the domain is r. Whereas the range can be something, whereas here range is restricted to minus pi by 2 to pi by 2. So generally they are not same functions. So we observe that on the given domain, that means here -1 to 1, sine inverse of sine x is always x on the concerned domain. You see, cos of cos inverse x is always x. In the same way, tan of tan inverse x is also x. In the same way, you can write cot, secant, cosecant. No problem with sine of sine inverse function. The main important thing is problem with sine inverse of sine x, because suppose if I give say some 320 degrees, like you can say, yeah, so pi by 6 is fine, or pi by 3 is 60. Suppose if I take 7 pi by 3 as input, 420 degrees, the output cannot be 7 pi by 3, because sine inverse output must be in the interval minus pi by 2 to pi by 2. So friends, you won't get x always. So sometimes you may guess. So how to handle this? To handle that, my dear friends, here we try to remember this with the help of a graph. All of you please remember this. Sine inverse of sine x, how to compute. One of the most important concepts of this topic. You take x-axis, y-axis, plot 0. You can take like this, 0, pi by 2, you will say pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi. In the same way here also friends, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Like this you plot. Here also you plot pi by 2 to minus pi by 2. Right? Now dear friends, what I suggest is you just friends, like y is equal to x. Try to remember this. Then passing through pi, it comes like this. Then it goes through 2 pi, it goes like this. In the same way friends, you can draw rest of the part of the graph also. So there is an interesting way to remember the names also. You see, let me give you this technique. You see, this is a line parallel to y-axis. So this is x. Let me choose some different color. X minus this number, x minus 0. This is a line which is parallel to y is equal to minus x. Whenever you write minus x, you add this number pi. Whenever you write x, you subtract this number minus 2 pi. Here also friends, this is minus x, add this number minus pi. This is plus x, subtract this number plus 2 pi. So what way this is going to help us friends? For example, you want to compute sine inverse of sine, say I can say like 4. 4 means 4 radians friends. Pi is near to 3. 3 pi by 2 is around 4.5. Here it would be 4. So here the definition is minus x plus pi. So minus 4 plus pi. Pi minus 4 is the answer. So to compute such things, this graph is going to help us. So it's very, very important you must practice. For your kind information, friends, cosecant inverse of cosecant x also almost the same graph. Of course, it is not defined at, you see, certain points like 0, pi and all, but the same graph. So to compute sine inverse of sine x or cosecant inverse of cosecant x, you can use this graph, dear friends. In the same way, you try to go with cos inverse of cos x graph. This is very interesting, easy also when compared to previous. You plot only multiples of pi, 0, pi, 2 pi, 3 pi, here also minus pi, minus 2 pi, here also you put pi, dear friends. The graph would be like 0 to pi, like this. pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi. Like this you can continue, dear friends. Now you can apply the same logic like earlier to write these graphs. So name it, friend. This is x parallel y is equal to x. No, x minus 0 minus x plus 2 pi. This is x minus 2 pi minus x plus 4 pi you will get, because here it may be 4 pi. Okay, similarly here this is minus x plus 0, this is x minus of this plus 2 pi. Like this graph helps, friends. Even the same kind of graph for secant inverse of secant x. Yes, yeah. So friends, of course this is not defined at odd multiples of pi by 2 for secant inverse of secant x. It doesn't matter, wherever it is defined you can use this. For example, you want to compute cos inverse of cos 9. 9 means 9 radians. It will be around 3 pi. So it will be here, friends. This definition is x minus 2 pi. 9 minus 2 pi is the answer. Right, friends? In this way, you can easily draw the graph of sine inverse of sine x, cos inverse of cos x. Even you can also draw the graph of, you see, tan inverse of tan x as well as cot inverse of cot x. For that, here also, like sine inverse of sine x, you can put 0, pi by 2, pi, 3 pi by 2, 2 pi. In the same way, minus pi by 2, minus pi, minus 3 pi by 2, like this. Here also you put pi by 2, minus pi by 2. So friends, here the graph will be, let me take the different color. This is same like y is equal to x part. Then again the same kind of graph here, same kind of graph here, even here also the same. So it's very easy, friends. Naming is, you see, x minus 0, x minus pi, x minus 2 pi, x plus pi. All will be having x plus something. Now if you want to go with cot inverse of cot x graph, it will be just like I can say cos inverse of cos x, because you just plot only pi's, 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, so pi. You just plot, friends, the same kind of graph you will get, but only single branch kind of. This, then second, third, only same kind of graph, but the location is different. Now you can name them easily. This is x minus 0, x minus pi, x minus 2 pi. This is x plus pi, x plus 2 pi. So friends, these 6 graphs what I have discussed here are very important to compute this. Sometimes we are getting question based on this. Friends, point number 1, this is the domain and ranges of the 6 inverse trigonometric functions. Second, sine inverse of sine x is same as x, whereas sine inverse of sine x is different from x. It depends on the x what we give to compute this kind of. We are having these 4 graphs, these are important. Next, friends, another important point, I can say fourth point, that is the graphs of sine inverse of s. Hereby I am going to give you some small technique to draw the graph, friends. To draw the graphs of sine inverse x, the domain is minus 1 to 1, the range is minus pi by 2 to pi by 2. Okay, friends. So let me draw the graph of sine inverse x, friends. At 1 it is pi by 2, at minus 1 it is minus pi by 2. So friends, at 0 it is 0. This is the graph of sine inverse x. Don't stop here. You just continue this arc here like this. and here like this is going to be the graph of, yes, the graph of cosecant inverse x graph. Yes, cosecant inverse x. And tan inverse of tan x graph would be like, it comes like, yes, goes like this. Rough graph is enough, friends. Rough graph is enough. No need to be too specific. You see, the black colored one is sine inverse x. Yeah, sine inverse x, and green color one is going to be cosecant inverse x, red color one is going to be tan inverse x. From this you can observe that all the three are increasing functions, kind of. You see, especially sine inverse x is increasing, tan inverse x is increasing. Cosecant inverse x, as x increases, value getting decreased, and here also decreasing. Fine, that is one point. In the same way, to draw the graph of the other three functions, you plot -1 to 1. So here you put pi by 2, here you put pi. Now first you try to draw the graph of cos inverse x. At -1 pi and at pi by 2 it is 0. At 1 it is going to be like this. This is the graph of cos inverse of cos x, dear friends. Then you just imagine a dotted line. Now you just try to draw the other part of the graph like this. It is going to be this. This is going to be secant inverse x graph. The next cot inverse x graph would be like, you can take like this, friends. It is going to be like same S kind of. Yes, you can see the rough graphs of these at one place, because you see here the output is 0 to pi for cos inverse x, secant inverse x, as well as cot inverse x. These three behave alike, and these three behave alike even in the graphs also. You see, friends, cos inverse x is a decreasing function. For example, cos inverse x less than cos inverse y, if you want to solve this kind of inequations, as cos inverse is a decreasing function, you will get x greater than y. Even same for cot inverse x also, you see it is a decreasing function. So for such cases, you need to answer with the help of graph itself. Right, dear students? Then next I can say the other properties. You see, so far we have given the definition first, then the computation of sine inverse x kind of, then the third sine inverse of sine x kind of, then fourth one is graphs, dear students. After that, fifth one, when one particular inverse trigonometric ratio is given, sine inverse x. Suppose x is a positive quantity, then you just treat like x by 1. Generally we say x is opposite side, this is hypotenuse. Just it is a mnemonic, friends, to remember. If at all you want to write in terms of cos inverse, you just write adjacent side by hypotenuse. If at all you want to write tan inverse of, you will get opposite side by adjacent side. Do remember, this is all when x is positive. Of course, cot inverse you can write adjacent side by opposite side kind of. Secant inverse of you can write, you see friends, 1 by root of 1 minus x square. Of course, cosecant inverse, you can write 1 by x. This result helps us to write one inverse trigonometric ratio in other terms. Not only that, friends, next result, sixth one, I can say sine inverse of minus x is minus sine inverse x always, because its range is like minus pi by 2 to pi by 2. Same is for cosecant also. Yes. So what about tan inverse? Tan inverse of minus x is also minus tan inverse x. Whereas friends, cos inverse of minus x, there is a disadvantage for this function. It must be like pi minus cos inverse x, because its range is 0 to pi. So similarly, secant inverse of minus x you can write like pi minus secant inverse x. Even in the same way you can write cot inverse of minus x, you can write like pi minus cot inverse x, friends. So interestingly, for these three functions, pi minus comes because of their range. This is another important one. Now if at all you want to write based on this, first you simplify this, next you can apply this formula. Right, friends. Seventh observation is, friends, sine inverse x plus cos inverse x is nothing but pi by 2, and tan inverse x plus cot inverse x is nothing but pi by 2. Even secant inverse x, yeah, plus cosecant inverse x is also going to be pi by 2, dear friends. Yeah, you see here, one function is having the range minus pi by 2 to pi by 2, other is having range like 0 to pi. This is why the result is getting hold good here. And another important point, friends, sine inverse of 1 by x can always be written as cosecant inverse x. Of course, x should not be 0. Cos inverse of 1 by x can always be written as secant inverse x wherever it is defined. Whereas tan inverse of 1 by x is cot inverse x, you can write only when x is positive. The problem is, friends, here in this result both are having range like minus pi by 2 to pi by 2. Here both are like 0 to pi. Whereas tan inverse is having minus pi by 2 to pi by 2. Cot inverse is having range 0 to pi. This is the reason. For that, you see, when x is positive, okay. When x is negative, what should we do? Just to recall, put x is equal to minus 1. Tan inverse minus 1 is minus pi by 4. Cot inverse minus 1 is 3 pi by 4. So you have to write minus pi to equate. So minus pi plus cot inverse x. Yes, friends. So this is another important point. After these points, dear students, yeah, we have done with the major part of this. Then ninth one we can say, yeah, certain results, friends, like tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy, we can write, provided, friends, when the denominator is positive, it is okay. If the denominator is negative, observe whether both xy are positive or not. If yes, you write the same formula plus pi. If denominator is negative and both xy negative, you write the same basic formula minus pi. This is very important and interesting point, dear students. Yes. So this I call it as basic formula. So you write this basic formula as it is, plus pi you have to write. Yes. Minus pi you have to write here. Let me repeat. Whenever tan inverse x plus tan inverse y is given, you just apply like tan inverse of x plus y by 1 minus xy. If the denominator is positive, you write basic formula. If it is negative, check whether xy both are positive or not. If both positive, plus pi, both negative, minus pi. What if one positive, one negative? In that case, anyhow xy is negative, 1 plus xy will be positive. It comes under first case. For example, friends, you want to compute tan inverse 1 by 2 plus tan inverse 1 by 3. How to do? Tan inverse of x plus y by 1 minus xy. You see, denominator you got positive, so no problem, you can go ahead. This is tan inverse of 5 by 6 by 5 by 6, which is 1, which is pi by 4. Next, suppose you are given a problem like tan inverse 2 plus tan inverse 3. You just try to apply this formula. Tan inverse of x plus y by 1 minus xy. You see, after writing the formula, you got negative here, both xy positive, so a basic formula plus pi. In fact, this is, friends, 5 by minus 5 is minus 1 plus pi. Tan inverse minus 1 is minus pi by 4, right? Plus pi, which is 3 pi by 4. Apart from these, we are having so many formulae in other cases, but rather all those things, these are the minimum required formulae. With the help of this, you can enter the problems, dear students, right? So let us move to the problems, right, friends? So almost I have given 10 important formulae in inverse trigonometry. Once you are thorough with these, it is enough, you can enter the problems. First question, you just try to answer the domain of this function, dear students. While finding the domain, the first point is input of a logarithm should always be positive. Am I correct? And base of the logarithm must be positive other than 1. Here anyhow base is e, no problem. Sine inverse x must be greater than 0, strictly greater than 0. Now, how to say, excuse me. Yeah, sine inverse x positive means you can observe that sine inverse behavior. Basically, x is inside of sine inverse x. X can have the chance to be minus 1 to 1 only. If you give negative numbers, you will get a negative output. If you give 0, you will get 0. So the input must be open 0 to closed 1 so that the output of sine inverse will be positive. So x can be open 0 to closed 1. From answer to question also, you cannot give up to 2. Sine inverse is not defined. You can't give 2. You can't give negative even. You can easily say option A is the right answer. Okay, friends. Then, yeah. Find the range of this function sin inverse x plus cos inverse x plus tan inverse x. You see, most of the student can answer this problem easily. Sin inverse x plus cos inverse x is pi by 2 plus tan inverse x. Arey yaar, tan inverse x minimum value is minus pi by 2, maximum value is pi by 2. So when you do this, you will get 0, this is pi. So I can say closed 0 to pi or open 0 to pi. So two options are there. But friends, this is absolutely wrong. Most of the students go with this option or this procedure. But friends, before you apply the range, you observe the domain. Sin inverse x is meaningful only when x belongs to minus 1 to 1. Even cos inverse x is also meaningful only when x belongs to minus 1 to 1. Tan inverse x means x can be real number. So the domain for the definition of all these three, x must be in the interval minus 1 to 1 only. This is the domain. So in that case, anyhow, sine inverse x plus cos inverse x is pi by 2. We can agree that. So our function is pi by 2 plus tan inverse x. But you are giving values from minus 1 to 1 only. In this case, tan inverse is increasing function. Its minimum value will be minus pi by 4. maximum value will be pi by 4. So the sum is minimum pi by 4, maximum 3 pi by 4. This is the range, friends. Yes, this is the practical difficulty with math questions. Generally, these questions tempt us. We feel that this is a familiar question, we can answer it well, we will solve it, we get some answer. Unfortunately, that option will also be present in the options. Misleading questions, what we call. Here you will get 0 to pi generally. In fact, friends, if you kept this is also open, some students will go with this, some student will go with this, but in fact the answer is C. This is the reason why many students are getting less marks to score even 99 percentile in mains. So be careful with concepts. The answer is pi by 4 to 3 pi by 4. Option C is the right answer, dear students. Then next, yeah, how to simplify this? Yes, you see, here I can say, why can't we? Here the options are independent of m comma n. Why can't we go with certain options like m is equal to n? It is meaningful only, no? You see, tan inverse 1 minus tan inverse 0. I can say pi by 4 minus 0, pi by 4. If the answer is correct for some m comma n, it is true for in other case also, no? So I can easily identify the answer. If at all you want to do, you can go with tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy you can do. Rather, again cases will be there. Rather, the options indicate that the answer is independent of m comma n. So we can solve it. Next, friends. Yeah, you see this question? Sin inverse 3 by x plus sin inverse 4 by x is pi by 2. Then what is x? Yes, friends, actually sin inverse 3 by x plus cos inverse 3 by x. When this is added to cos inverse 3 by x, we will get pi by 2. So that means, friends, sin inverse 4 by x is equal to cos inverse 3 by x. From the options, x is positive. So can I write it as sin inverse of root of 1 minus 9 by x square? Yes. So sine inverse is 1 function. So you can write 4 by x is root of x square minus 9 by x. Anyhow, x is positive, friends. 16 is equal to x square minus 9. X is equal to 5. X is positive. You can take x is 5. And of course, if you are familiar with these problems, if x is, when sine inverse 3 by 5 is nothing but cos inverse 4 by 5. So you can easily say that when x is 5, the equation holds good clearly. So or else you can also try directly, dear friends. Then next, yes, sine inverse of sine 10. How to compute this problem? Undoubtedly, to answer this question, we need to take the help of, yeah, our graph. 0, you can take like pi by 2, pi, 3 pi by 2, 2 pi, yeah, 5 pi by 2, 3 pi, which is around 9. Yeah, 7 pi by 2, 4 pi. Somewhere our graph will be here, pi by 2. Then it comes like this, friends. Then it goes like this. Then next, like this. Can you name them easily? X minus 0, minus x plus pi. X minus 2 pi, minus x plus 3 pi. This is x minus 4 pi. Are yaar, 10 means 10 radian. Where is it? Yeah, this is 3 pi is around 9. 7 pi by 2 means 21 by 2, 10.5. 10 will be somewhere in the journey here. 10 will be somewhere here. So which definition should I use? Minus x plus 3 pi. So minus 10 plus 3 pi. Yes, minus 10 plus 3 pi, which is 3 pi minus 10 is the answer. Option C is the right answer. Clear, friends? In the same way, yeah, you see this question, friend. These kind of questions are very important. Tan inverse of, you see, infinite series or sum to n terms will be given. So you can write it as tan inverse of 1 plus 1 into 2 is there. You try to write 2 minus 1, which is tan inverse 2 minus tan inverse 1. Denominator is also positive. Can I write? The second one, you write this 1 as 3 minus 2. This becomes tan inverse of 3 minus 2 by 1 plus 3 into 2 will give you tan inverse 3 minus tan inverse 2. In the same way, the last term will be tan inverse n minus tan inverse n minus 1. Right? You just add all these things. So these two cancel, these two cancel, these two cancel. So tan inverse n minus tan inverse 1. So friends, you can write tan inverse of x minus y by 1 plus xy. N is a natural number, denominator positive, so it is fine. Tan inverse of n minus 1 by n plus 1. Friends, hope you got this result. Sometimes the same problem will be given for infinite terms, like tan inverse of 1 by 1 plus 2 plus tan inverse of 1 by 1 plus 6, like that, infinite terms. So students will be writing this, they keep on cancelling this, everything is cancelled, they feel that minus tan inverse 1 is left, so the answer is minus pi by 4, which may also be present in the options. But in fact, friends, as n tends to infinity, you may get cancelled, but still tan inverse n will be left. In fact, you can stop the problem here. Yeah, tan inverse n minus tan inverse 1. Friends, which is as n tends to infinity. Yeah, as n tends to infinity, friends, this goes to pi by 2 minus pi by 4. The answer becomes pi by 4. Here also you can apply limit n tends to infinity. Since tan inverse is, I can say, continuous function, you can take the limit inside. Tan inverse 1 pi by 4 it becomes. But most of the student will be doing this mistake. They will be cancelling the thing. They feel that this term is also cancelled. They get the answer minus pi by 4 when it is given. So be careful, friends. Whenever you are given sum of infinite terms, you take the sum to n terms, then keep on cancelling. Then after this, after writing sum to n terms, then you apply limit n tends to infinity. Then you will get the right answer, friends. Hope you got my point. Clear? Right. Then next, dear friends, yeah, you see this question, how to do this? Yeah. So this one, you can write the denominator part. First, you try to write like 1 plus m power 4 plus m square plus 1 2m here. Friends, this is a very familiar expression. Whenever you see this, you can write it as 1 plus m square plus m plus 1 into m square minus m plus 1. That's it. So I think you know, friends, its factors are these two, whose difference is 2m. you can write m square plus m plus 1 minus m square minus m plus 1. Perfect it is. So as the denominator is always positive, it is m square plus m plus 1 minus tan inverse of m square minus m plus 1, my dear friends. Yeah. Now, you see, these are such a way that method of differences that we see in sequence and series. In place of m, if you write m plus 1, you will get this. Put m is equal to 1. What will you get? Tan inverse of 3 minus tan inverse 1. Put m is equal to 2. Tan inverse of 4, 6, 7 minus tan inverse of 2. No. Yeah, 3. Next, put m is equal to 3, you will get tan inverse of 9 plus 3, 12 plus 1, 13 minus tan inverse of, when you put 3, so 9 minus 3, 6 plus 1, 7. You see, alternate terms get cancelled. So the last term that is left is m is substituted by n. So friends, you are left with tan inverse of n square plus n plus 1 will be left here minus tan inverse 1. So you can leave the problem here, or the problem is in single tan inverse. You can write tan inverse x minus y by 1 plus xy. Option A is the right answer, friends. Am I correct? So these kind of questions are also very, very important here. The next, friends. This question, you see, the domain of sine inverse of 2x plus 1 by 3. It's a very ordinary question. 2x plus 1 by 3 input must be between minus 1 to 1. Multiply with 3, minus 3 less than or equal to 2x plus 1 less than or equal to 3. You subtract 4, 1. So that minus 4 less than or equal to 2x less than or equal to 2. Divide with 2, minus 2 less than or equal to x less than or equal to 1. Minus 2 to 1 closed interval is the answer, dear friends. Then next, you just see this question. Sine inverse of tan of minus 5 pi by 4. Friends, first of all, this minus can be brought outside because tan is odd function. That can also be brought outside. This is sine inverse of tan of 5 pi by 4. Tan 5 pi by 4 means pi plus pi by 4 minus tan pi by 4, which is minus sine inverse of minus 1, which is, friends, sine inverse 1. Sine inverse 1, I can say just pi by 2. Yeah, sine inverse 1 is pi by 2. It is a simple simplification based problem. Yeah, you see this question, friends, many times this kind of questions are given. So here best thing is, why don't you proceed from answer to question? You put 1 by 2, sine inverse 1 itself pi by 6, cos inverse 1 by 2 is pi by 3. It will not work out. Root 3 by 2 you put, sine inverse root 3 by 2 means 60 degrees minus cos inverse root 3 by 2 is 30 degrees. So which helps to be pi by 6? This is fine. If not, I would have tried with C and D. So don't try to solve the equation in a monotonous method. You just utilize the facility of options. You will get the answer. Next, friends. This kind of question just now we have done. So sine inverse of x by 5 plus cosecant inverse, you can write sine inverse of 4 by 5 is equal to pi by 2. So you can write sine inverse of x by 5 plus cos inverse of, you can write 3 by 5 is pi by 2. So this should also be 3 by 5. So x must be equal to 3. Right, next. Yeah, in pi by 2 to 3 pi by 2, sine inverse of sine theta. You see, friends, I think you do remember x from here to here only. X minus x plus pi. That is pi minus x. pi minus theta is the result, friends. Okay, then you see inverse trigonometric equations kind of sign. Why don't you proceed from answer to question? Yeah, put x is equal to 0. 0 minus cos inverse 0 is minus pi by 2. Sin inverse of minus 1 is minus pi by 2. Perfect. 0 should be there in the answer. You can take this. You can take this. Don't try to solve in a routine way. Next, friends, here also my suggestion is happily substitute the things and verify. That is fine. Don't try to solve by routine methods. You see, friends, here you can give some numbers for A and B. Rather, it is like alpha, it is like beta. Tan of alpha plus beta means tan alpha, which is 1 by A plus B, plus tan beta b by a square plus ab plus 1 by 1 minus tan a tan b, a plus b into this is a square plus ab plus 1. This is what he is expecting about you. Why can't you just simplify this, friends? It is going to be a square plus ab plus 1 plus ab plus b square by, you just multiply this, a plus b into a square plus ab plus 1 minus 1. You just see, friends, this is going to be a square plus 2ab plus b square plus 1. So yeah, you just multiply. Here also, if you take a common, a plus b, or you can write like, yeah, a plus b into, this is, yeah, sorry, here b is there, we forgot this point, b. So here also you will get minus b. Yes, yeah, you just simplify, friends. A cube plus a square b plus a plus ba square plus ab square plus b minus b got cancelled. You just take a common. See, you will get a square, you will get ab, you will get ab plus 1 plus b square. Everything is fine. So 1 by a is the answer, dear students. So friends, in the same way, here I have incorporated certain problems. You don't try to apply the formula like x tan inverse x plus tan inverse y. In such case, why don't you apply tan on both sides? So it is like alpha plus beta is equal to pi plus gamma. Apply tan alpha, yes, plus tan beta by 1 minus tan alpha tan beta. The cancellation would be x plus 1 by x is equal to tan 180 plus theta is minus tan theta, which is minus 7. So plus 7. It is a simple equation, friends. X plus 1 into x is x square plus x square minus 2x plus 1 by, this is x into x minus 1 comes in the denominator here, which is minus 1 by x comes here is equal to 7. X cannot be 0. You can cancel this. 2x square minus x plus 1 is equal to minus 7 into minus 7x plus 7. Yeah. So that, friends, 2x square plus 6x minus 6 equal to 0. You just get a quadratic equation, friends. X square plus 3x minus 3 equal to 0. You just check whether any real root is possible in the options. Accordingly, you can identify the answer. You just check whether your calculation correct or not. Tan alpha plus tan beta by 1 minus tan alpha tan beta is equal to tan 180 plus theta is minus tan theta. Okay, it is plus, sorry, this is plus tan theta, so this is tan of, this is minus 7, so here you will get minus 7, so this is going to be plus 7x minus 7, here it is, so 2x square minus 8x, the equation would be like, yeah, 2x square minus 8x plus 8 is equal to 0, that is x square minus 4x plus 4 equal to 0, x minus 2 whole square equal to 0, x is equal to 2, dear friends, right? In this way, most of the questions you can easily handle. I have given such kind of questions here. Anyhow, I am going to incorporate this in the notes part. You see, this part is also very easy to compute and try, dear students. So in a nutshell, inverse trigonometric functions in the sense 10 important formulae followed by some standard 30 questions you practice. It is enough. You can undoubtedly attempt the question in JE main. Undoubtedly, you can attempt, dear students. That much easy topic it is. Don't miss the topic. And I suggest, you see, apart from the topics, what we have done matrices, we have done vectors, we have done 3D, from where you are going to get 5 questions easily in mains. After that, you are going to get, you see, we are going to take up such simple topics from which small in size, but you will definitely get question from that. So one of such topics is this one, inverse trigonometry. Another is trigonometric equations. Another is differential equations. Our next topic is going to be differential equations tomorrow, mostly at 4 o'clock, right? Don't miss the class and stay tuned to Infinity Learn, where you can find wonderful kind of stuff, synopsis, revision in brief in half an hour, and we will discuss good number of questions in the rest of the time. Right, dear students? Hope you have enjoyed the sessions, and none of you are giving your, many are calling to me, are saying that, sir, the class is very nice, useful, you have revised. You see, where in most of the videos we will be finding hardly 4 or 5 problems they explain, but you are explaining so many problems, synopsis in brief and all, so very very helpful to us, like this many students are saying. Rather, why don't you mention this in the comments? Why don't you encourage the faculty in terms of you see, your real satisfaction, so that we will also know what you are expecting about, right, dear students? Fine. Yeah, so stay tuned to Infinity Learn, my dear students. Thank you. That's all for the day. See you in the next class with some other topic. Bye. Stay tuned to Infinity Learn.